Physics Lab 4. The purpose is to observe the motion of a mass suspended by a spring. Important equations: spring force, velocity update, position update, kinetic energy, potential energy, and spring potential energy. The idea is, given the spring constant mass of an object, the relaxed spring length, and initial position, the oscillation of the spring system can be modeled. The result was that the model semi-accurately predicted the real motion of the spring system. The spring, point mass, and gravity force are all in the system, and there's nothing in the surroundings. Process, assumptions, and conditions. Process. The given starter code was edited to function correctly. The code was ran and the outputs were analyzed. Assumptions. There's no air resistance on the spring system. The mass of the spring is negligible, and the object is treated as a point mass. Conditions. Object mass, 0.402 kilograms. Relaxed length of spring, 0.123 meters. K, 6.83 Newton meters. The model was given in the procedure. The initial conditions were updated. Equations for spring force, the spring's position, and Fnet were created. Position and velocity update formulas were input. Results. The output of the code shows multiple things. The ball on spring remained close with the experimental data of the red ball. Delta U grav equals negative delta U spring and vice versa. The change in energy remains zero throughout the whole graph. The ball travels in an oscillating motion. The above graphs show the difference between the model and actual data. What does it mean? The energy principle is satisfied. The graph from the previous slide shows that the change in energy of the system is zero throughout the whole experiment. My estimate for the X oscillation period is 1.52 seconds. And for the Y oscillation period, it is also 1.52. The estimates are the same. Possible error. The object was treated as a point mass. No air resistance was accounted for. Conclusions. The model accurately predicted the motion of the object. The energy principle holds true for spring systems, and the X and Y oscillation periods were the same.